raw material requirements, and material handling. In this section of the plant audit, we want to make sure not only that the materials being used are in compliance with CSA, but that the equipment used to handle and dispense the materials are in good working order and prevent cross-contamination or degradation of any kind during the transfer and handling process. Cementing materials test documents should be current and readily available for inspection by the auditor. Test reports should show each material's compliance to CSA standards and should be reported by a lab certified to CCRL or AASHTO. The list of materials presented here is historically what's been used in the Alberta market. With the supply from local fly ash sources becoming more disrupted of late, other sources may enter the market from nations further afield, and their compliances should be documented by a reputable firm certified to the entities previously mentioned here. Other supplementary cementing materials may be coming to Alberta market as well and should be reviewed for compliance as well as identification of source origin. At any rate, all cementing materials requirements can be found in the CSA A3000 Cementitious Compendium. All cementing material silos should be inspected for tightness and free movement at the discharge opening to ensure that no materials get hung up in the system and that no materials are exposed to any contaminants or sources of moisture that could prehydrate or degrade them in any way. Silo storage should be configured to prevent cross-contamination of differing products. Inspect split silos for cracks or splits that allow one product to be blown over into the other when one split compartment is filled. The policy and process for managing dust collector materials should be well documented. Dust control policy and process should take into consideration the impact not only on safety and environment, but also on the durability of the concrete produced by the facility. Though some facilities are only equipped with one common dust collector, it is not recommended. When one defines a least affected cementing material solely from a concrete strength perspective, they may be compromising the concrete produced if a minimum supplementary cementing material cement replacement rate is required to ensure long-term durability. For example, if a common baghouse is always vented to the fly ash silo, and the producer needs a minimum 20% fly ash cement replacement rate to achieve sulfate resistance or to mitigate the potential for alkali-silica reaction, they may not be meeting that requirement if the fly ash silo is contaminated with Portland cement from dust collector fines. This may not be an issue if the producer uses more than the minimum fly ash cement replacement rates to produce concrete that mitigates the potential for these durability issues, and the producer reintroduces the dust collector materials to the least affected material at a very slow, controlled rate over an extended period of production. There should also be a written policy in place to define the protocol for sweeping trailers when switching products hauled in a given pneumatic trailer to ensure that any cross-contamination is prevented, and that if it does occur, that it's not to the extent of compromising the performance and durability of the concrete produced. All pipe stems, where pneumatic trucks hook up to transfer products into silos, should be clearly marked with the cementitious material product type, and in some cases, the product source when multiple sources of the same material type are used in production. Any product type or source switch information should be entered immediately into the batching system to ensure any program proportioning adjustments are included in subsequent loads of concrete produced. Proportioning minimums for both strength and for durability purposes are specific to the cement and supplementary cementing materials used. For example, the minimum replacement rate of one source of fly ash may be quite different from one cement than with another fly ash source. And then, if the fly ash source is kept constant, but the cement source is switched, an adjustment may be necessary in fly ash cement replacement rates to ensure continuous production of strong and durable concrete. Suppliers should have current reports on file at all times of the chemical and physical parameters, including strength activity indexes of all fly ash sources used, as well as sulfate resistance and alkali-silica reaction mitigation minimum cement replacement rates for all combinations of cement and fly ashes used in production. If silica fume is used by the facility under audit in combination with fly ash and cement to produce concrete for C-1, CXL, A-1, and A-XL exposure classes, rapid chloride permeability reports representative of the concrete produced with any or all combinations of cementing materials used by the facility should be on file and readily accessible. As mentioned earlier, the auditor should be looking for current documentation indicating that the cementing materials used comply with CSA and that they've been tested by a lab certified to CCRL or AASHTO. Aggregate storage piles or bins should be configured to prevent any cross-contamination and should ensure that the materials remain clean by using tarps weighted down to prevent fugitive dust from entering them, especially fines that can coat aggregates and prevent the development of good aggregate paste bonds. Tour the piles to see if there are any of these types of issues and note any as nonconformances in your audit report. If stockpiles are in the process of being built at the time of your visit, ask for a tour and ask what their protocol is for aggregate storage, and ask to see any written protocol that may exist to ensure a concerted effort is being made to prevent segregation or contamination. Ask where plant site aggregates are coming from and whether they've ever run sieves on samples from their piles to compare to the reports received from the source supplier for validation of compliance. Inspect bins for wear and charging to ensure the potential for segregation or cross-contamination is prevented. The concrete producer must provide a letter from certified testing firms certifying that the aggregates drawn from current stockpiles at the facility to make concrete conform to CSA A23.1, A23.219. In particular, CSA A23.2-30A, Clause 8.5 states, as a minimum, testing to verify compliance with the requirements of clauses 4.2.3.3, 4.2.3.4, 4.2.3.6, 4.2.3.7, and 4.2.3.8, and tables 10 to 12 of CSA A23.1 shall be conducted on a yearly basis, and the test results shall be made available to the owner upon request. In the case of aggregates stored in stockpiles or similar distinct and identifiable lots, test results older than 1 year may be accepted by the owner when the supplier provides affirmation that the results submitted pertain to the identified lot and are representative of current supply. An adequate supply of potable water should be available for production, with pressure sufficiently constant or regulated to prevent interference with the accuracy of measurement. Unregulated flow rates can vary significantly if well water is used. If water is only metered, the meter shall be calibrated every 6 months. Ask for and submit water meter calibration records, both current and past, to look for consistency. If water is all weighed, make sure the scale used for weighing the water has current and past scale calibration test report records dated at compliant intervals. Domestic water supplied by municipalities should be fit for making concrete. Potable well water test records should be reviewed by the plant auditor for consistency. A formal written protocol for using recycled wash water should be available for inspection and should include a formal validation procedure and scheduled frequency that is date documented. Admixtures should be stored in tanks or containers within environments that prevent freezing of their contents. Liquid calcium chloride is one exception because it does not freeze. All admixture tanks or containers should be clearly identified with current WHMIS labels. Any liquid admixtures that are not stable solutions shall have their tanks or containers equipped with agitators that are maintained in good working order at all times. Check to see if this is the case at the facility that you're currently auditing. Each admixture shall be measured and discharged separately. Trace the lines of the admixture system to ensure they're kept separate, and examine batch sequence data to ensure incompatible ones are not introduced simultaneously at a common entry point into the mixer. Please ask to review the most current and previous 2 admixture dispensing system inspection calibration reports for compliance with the inspection interval, that being every 6 months for plants open year-round and annually at the beginning of the season for seasonal plants. The producer should also have a letter on file from their admixture supplier stating that the admixtures in use conform to CSA A23.1. Submit a copy of the most current reports with the audit checklist. For concrete produced in sub-freezing weather, plant heating facilities for water, admixtures, aggregates should be provided to ensure that concrete temperatures conform to CSA A23.1. Concrete is not to be made with frozen materials with the exception of ice replacement of water in summer when stringent concrete temperatures are stipulated for critical pours. Look for boilers and steam lines in sand pile bins. Ask to see evidence of boiler functioning during current or most recent winter operations. Ask to see batch tickets with ambient and concrete temperatures recorded as evidence of dispatch of concrete within 10 to 35 degrees Celsius.